Navigation systems mainly aid pilots in finding their current location. This is especially helpful during transcontinental flights, flights into areas with complicated airspaces, and flights with adverse weather conditions. There are so many things happening at once when flying, and navigational systems help by doing some calculations for you and interpreting data from sensors in a way that is not only integrated but also easy to understand mid-flight. Navigation systems are incredible tools for pilots, but they aren't magic. There are complex systems in place to ensure accuracy of navigational systems, no matter what kind of navigational systems you have. Something that is analog uses varying physical quantities or qualities to directly display information on itself. Something that is digital is something that is electronic and especially to computerized technology. An accelerometer is an instrument for measuring acceleration. Orthogonally means it has the qualities of orthogonal, meaning intersecting or lying at right angles. Torque is a turning or twisting force. And a pendulum is something suspended from a fixed point and allowed to swing freely under the influence of gravity. What makes a navigational system? A self-contained navigation system uses its own sensors on the aircraft and doesn't rely on data from any other source. Externally referenced navigation systems use references from the ground or space to receive their navigational information, but are much more expensive. The ideal system has four major components: being able to show position and velocity relative to the ground, be able to accurately and reliably position and steer the aircraft anywhere in the world. It has to be self-contained, meaning that it would not use anything on the ground or space at all to get its data, and it has to work well if you make an unplanned deviation, as well as work at any altitude or speed. There are three main components to navigational systems. A computer, which can be analog or digital. Analog computers are very specific and they're not easily changed between functions, and digital are, and they are used for multiple purposes, but you have to make sure you have the function you want it to do ready before you fly, or else you're not going to be able to change it during flight. These systems can use a variety of sensors, but the examples here are the Astro Tracker, the heading indication system, the VORs, the true airspeed indicator, a gyro, and an accelerometer. It also needs a user interface so that you can see the information and that you can input your own data or information into the system. So what does make something a navigational system? A navigational system is a system of the previous components, the computer, the sensors, and the user interface, that work together to get the most accurate positioning possible. What do navigation systems look like? Well, they can look like anything. It can be a fairly normal system, it can be a super complicated system that you see on like giant airplanes, it can be your iPad, it can be a small handheld device, it can be a whole bunch of things. You have them on your phones. They can come in many forms. INS, or Inertial Navigation Systems. It is also considered an ideal system. So how does INS generally function? By using data from sensors that aren't affected by the weather, it uses your direction and speed, as well as a known starting point, to calculate your current position. So basically it says you started here, you went this fast, this way, so you should be at this point. That's basically how it works. Every INS system has 5 basic components. Starting with accelerometers, they basically show when you start and stop going in the X, Y, and Z axis directions, so forward and backwards, side to side, and up and down. For these to be accurate, they have to be horizontal, and they have to line up with the Earth. And so, because of gravity, they need to have a stable platform, which is kept in place by the gyroscopes. Stable platform basically it's basically always straight, kind of. but it can move, and the gyroscopes keep it suspended in space, basically. The integrators take the data from the accelerometers and they integrate them into data, into a whole bunch of numbers that the computer will process and turn into usable navigation data. The information picked up by an accelerometer is susceptible to gravity, or it can be changed by gravity, and it can cause a massive error in distance computation. So to prevent this, Dr. Maximilian Schuler showed that a pendulum with the Earth as the middle would have a period of 84.4 minutes, and that would cancel out this effect of gravity on the accelerometers. GPS, or the Global Positioning System. So the GPS system is divided into 3 different segments. The space segment, which consists of the 24 satellites rotating around the Earth in the Earth's orbit, with a minimum of 4 satellites in view at all times, anywhere in the world. So they're put in specific patterns so that everyone can see them. The user segment has, it's basically all the equipment you need, and it uses the data from the satellites to determine the user's position, altitude, and velocity, and can also test the accuracy of the information being received. The control segment is a whole bunch of control stations, monitor stations, ground antennas, everything to track the accuracy and to make sure that everything is still functioning. Below is a map kind of showing where they are all across the world. So basically how the GPS works is the satellites in space are orbiting around and they transmit data to the user equipment, and the user can use these to see where they are, how fast they're going, and other information like that. And then everything is monitored by the control segment, which makes sure that the satellites are accurate and that they're still in working order. Some possible errors that can occur with GPS systems are user equipment clock error, satellite clock error, ephemeris error, and atmospheric propagation error. User equipment clock error and satellite clock error are kind of related in that the user equipment clock error is the difference between the accuracy of the quartz clock in the user equipment and the atomic clock in the satellite. And the satellite clock error is the difference between the much larger atomic clock on the master GPS system and the smaller atomic clock on the satellite. The ephemeris error is basically trying to guess where the satellite is, and to get more accurate data, the satellite predicts where it will be and compares that to where it actually is at that point in time, and that gives us more accurate positioning on the satellite. The atmospheric propagation error is basically the difference between a signal from it coming through at the speed of light and the fact that it's been slowed down by our ionosphere. I used the Flight Navigator Handbook, the Merriam-Webster Online Dictionary, and I used some Google search for some images.